related to shell environment variables and all kinds of things, and security and what not to do, and how shell check can save you and all that stuff. And while we were doing that, we came across another thing that we really need to talk about. This is not something they'll talk about. I try to make videos about things that are not going to be commonly discussed. And in this case, I want to talk about the olden days, way back when the Unix guys taught me at Teleport, and they were all guys. There were women there in other industries, but not in that particular take. And they taught me how to write a secure shell script. And they had a couple things that they would have us do that are not done at all today. They're completely ignored. And I want to talk about them. So the first thing is, typically they would write a shell script like this. This is the one we were using before from another program. I'm kind of giving away the secret there if you saw. But we do bin bash or bin sh, doesn't matter, right? We'll say bash. And they would say, the first thing would be, you do ls or whatever. And they would say, use the actual explicit path. That was one of the rule number 1. So the first rule is, and this is from them, not me. Okay, so always use an explicit path. And I know that people cheat on this constantly. I blame the Ruby people. The Ruby people were the first people who started to do this. User bin env bash, right? And the reason they do that is because it's more convenient to send to somebody. So they write a program, or Ruby or Python, whatever. They send that program to anyone, and because user bin env is really established and it's not going to move around. It's a binary, by the way. That will run. This is exactly it's a functional equivalent of just putting bin bash. However, it's much different. What user bin env does when you do this is it actually looks, when you run env, it prints out your entire environment. And mine's messed up because they got colors in there and stuff. But it prints out everything in your environment. But if you use env with an executable, it will run the executable. And what it does is it does an implicit which ls and then runs the full path on that. So when you do env ls, you can't see it, but it's actually the same as running user bin ls. It's the same thing. And it's one of the kind of esoteric, weird, things about the env program. Run a program in a modified environment. And that's what it was designed to do. So the fact that people are using user bin env to search through the path and find the right thing to run, or at least the first thing to run, and we're going to get to why that's bad in a second, is they do it because they're lazy. And they want to send out their program to their friends and stuff, and they have Macs and it's user local bin and other here, it's over here. And they're like, you know what? I just want the script to work for these people. I want them to be able to curl it down and run it straight from bash, which is a fucking disaster if you're doing that. It's so insecure. So they put it in there and it's stuck. And now it's infected the rest of the world. Everybody wants to do this because it's convenient. It's a nice way to share your scripts. It runs anywhere. I can put everything. That's just wrong. And in the old days, we actually cared about security and specificity. And if somebody wanted to change something like that, what would they do? They would come in and change the first line of the script. How hard is that? How hard is that? So rule number 1, use an explicit path for your shebang line if you want to write secure code. And why is that? How does env find it? How does env find ls or bash or anything else? How does it find it? As I said, it does effectively, it doesn't do it, but it does an effective which bash, right? And what does which do? Which locates a command. And again, it doesn't do a which, it does effectively the same thing. But it goes through the path and it looks through every path and it looks into that path to see if that thing exists. So, and if you don't know what a path is, that's this thing, okay? And I have a nice happy way to see it. So this is a path. A path says, okay, whatever executable files, they can be scripts, it can be commands, it can be whatever, compile code, it will check in each of these things as you go, right? That's the way it does. And it looks at each one, it's like, okay. And the first one it finds, env returns that one and it runs it, right? Anytime you type ls or anything like that, it's doing that every time. Every single time you type a command, it looks at the beginning of the command to see, okay, is this a binary? First of all, it has to find it. It's like, well, which ls are you talking about? And then it goes, which LS? And then it goes, oh, okay, yeah. And then the kernel or the file system, or it opens the file system, that file, and looks at the beginning of the file, which you can actually do if you really want to know. You can look at the beginning, user bin ls. You can see this in ELF binary, and that's the same number of bytes, by the way, as the shebang line. So this says, hey, I'm a binary. I'm just going to jam you right into memory and run you. But if it's not a binary, so like my Z program, right? Which Z, this is a nice tricky way to get to the right program, right? Without having to go to that directory. And people do like completion and shit with Z shell because they don't know that simple thing. It drives me nuts. So there's like bin bash. You can see the shebang line, right? The shebang line takes up exactly the same number of bits that the ELF header does. And so your program looks at those first bits and it decides what to do. It's like, oh, I have an interpreted script file. And then it reads the rest of this line as the binary to send the rest of the file to. And then every single line of this file is sent to magic numbers. Yes, every single line of this file is sent straight to whatever this program is, right? But in the case of user bin env bash, it evaluates this line. It actually runs it. So the first reason that you shouldn't do that is because it's inefficient. Right? I mean, I feel like, why am I running an extra program to go tell me where the program is when I already know where it is on 90% of the machines it's going to be on? And there's going to be that one Mac user that has his in user local, whatever, because they didn't run GNU utilities and set up all their paths properly. Why are we catering to the like 0.01% of people who have shit in the wrong place? And, or people who want to put things in different places like that. I think it's a bad idea. I don't do it. I don't hate people that do it, but I don't do it. I think it's a bad idea. So, and by the way, that was taught to me by the pedantic security people that I was raised by. Now, the second part of this is the path itself, right? In the old days, when you wrote a program, the first thing you put in the program was this: user bin and user local bin. And if you are doing any kind of systems Unix scripting, the first thing you did to ensure that your script was safe, you didn't have shell check back then, and a lot of times you're using POSIX shell, which is really crazy insecure. And the first thing you would do is you would export and chop down the path. Because by doing this, even if somebody manages to hack your path, and if you don't know what I'm talking about, do any number of hacker challenges that talk about this. You can go do a hacker challenge, and in the hacker challenge, they will say, break into somebody, get permissions for this program. Because why? Because it will look in the path. And by the way, never, I'm just going to put this, never, ever do this. I did this as an idiot when I was a kid, and I figured out why never to do it. Never, ever, ever put // in your path. I don't care how annoying it is to type / every time you want to run something in that same directory. Putting / in your path is a recipe for disaster on a multi-user system. But Mr. Rob, we don't use multi-user systems. It's all containers and it's just one system and I just do everything as root now. I know. I don't like it. But it doesn't mean you should just like throw security out the window, okay? Because hackers are going to look for it and they're going to use it. And so what I'm suggesting you do instead is you actually are aware of this. So don't put / in your path. CD path, yes. Regular path, no. If you don't know what CD path is, that's another video. But so this path here, if you put / in there, if I run ls and there's an ls in this directory or a pwd or a passwd to change the password or anything else, SSH, it will run the one that's in that directory, no matter where it is, no matter where I am. And so, I mean, if you want to hack somebody, this is what you do. You get on a system like that, with a dumb admin who doesn't know better, and you'd have to have a really stupid admin, and you get in a multi-user system, you say, hey, I need something to do something there. So you have them do as root permissions, you have them go into that directory, and you have them run password or something, say, I need to change my password. And then you make sure it changes the password and like calls the thing, but in the medium, you build yourself like a backdoor while they run it, and you just trolled them. You got full root access to the system. Super easy way to troll a really dumb admin. And the reason for doing that is because go over /. You go over /. So / is the current directory, right? So if I have an ls, right, If I put an ls in here, we're not supposed. I'm trying to show you the dangers of path. This is one of them, so it's kind of related to the conversation. So I'm trying to keep it fast though. So let's make a file in here. This is my boost directory. I don't know why I'm here. Let's make a temp directory. Make temp. Let's just make a temp directory. Actually, make temp -d. How about that? So let's cd into here. I don't want to screw anything up. So I'm in a temp directory, and I'm gonna make a file, right? So I'm gonna make an ls file, and I'm gonna chmod plus exit. I'm too lazy to type it, so that's what it is. ls-l. Now I got this runnable file. When I run ls, it runs that one, right? But when I run /ls, it runs this one. And there's nothing in it, which is a valid file, by the way. It ran without any errors because an empty file is a valid bash script, and it uses default shell by default. So if I do bin sh, I don't know, bin bash, right? So echo muahahaha, and then I do exec ls, right? Indistinguishable from not it, right? Bin ls. Is it user bin ls? I don't know. Which ls? Yeah, okay. Oops. So now we have user bin ls, right? So now I run an ls, and it's fine. I run .ls, and I can do something evil with the muhaha, you know what I'm saying? So then I say, and I could like create a file. I could put anything in muhaha that I want to. I'm not going to put something evil there because I'll get terms of service shut down because I'm showing you literally how to hack by doing that. But you can put anything in that line you want to. And then if the idiot admin has // in their path, then when they come in here to do an ls, they're not going to get that ls. What are they going to get? Now my ls it's not running this /ls because I have to do it explicitly. But if the stupid admin comes in, let's do it. Let's do this. Let's say path prepend prepend /. That's a little program I have now. If you run my path, you can see that. If you want that program, by the way, here it is. Pend. Oops. Oh wait, that's a script. There you go. There's a script. Here, I'll send it to chat. Yeah, cut that to chat. Did it go? It's gonna take forever. That was stupid. I should have eexed it to you. I'm sorry. That was kind of stupid. I'm so sorry. Let me eex it. I know y'all are watching. You want to see it. Let's pipe it to eex. Eex is like a paste bin. That's a much smarter thing to do. I'm really sorry I didn't do that. There you go. There's the link. It won't be there by the time you watch the YouTube video, but you know what to do. Being in heaven. Okay, so if you were to do this, I'm really sorry for that spam. So now what? When I run ls, which one is it running? Which ls? You see what it did? I just realized something. Ban streamer is running the evil one, right? If I didn't print muhaha, would the admin have any indication that they run the hacked version of it? No. They not know at all. The only reason that we know is because I actually said something muhaha. What run the one from user bin? No, it won't. Oh yeah. So if I see what you're saying. If you do yes, but it's still dangerous. I see what you're saying. Yes. So let's do that. Let's fix our path first of all. So I don't know how to do that. I don't have a path take off a path thing. Just have a path here. Echo $path. If you don't have that command, you can just do this. You do echo path. We can say export path equals I don't know. I'd have to go do it all again. I don't want to. I could awk off the front of it or something. I don't actually know. Let's do this. Oh, I just realized something I can do. Yes, we can do this. I can do this. There. That should take rid of it. Echo. Yeah, you can do that too. Actually, no. That would inherit the path. Yeah, I'm pretty sure that, yeah, exec inherits it all. That's why you do it. So, and we could test that if you want. But there, that was it. So just a little bit of just a little parameter expansion, and boom, we got the path back to where it needs to be. So let's take a look at this now. So if I do ls, we don't have that. Okay, so we're good. We're good to go. And it's the right one. So, but let's try it by putting it at the end. So I have an append, path append, pretty sure. Yep, path append dot slash. You don't actually need the slash. So we are tricking the admin. Why wouldn't he look in the directory? Because look, it's just too dangerous to do. It's not just an admin. It could be an admin. It could be a script. It could be anything, right? It could be a script that was written by somebody else. Anything that this is a surefire way. If you want to look at ways to break into a system, look for things that have // in the path, because what it does is it allows people to put things in the path that's in the wrong place, and so it ends up running the one they don't expect. That's the takeaway from this. That's the takeaway, and I can kind of leave that to rest. That's the takeaway, and that is the fundamental reason for number 2 thing that the admins would always tell me to do. They would say, look, if you want to be protected from any kind of tomfoolery or Tammy foolery, if you want to be protected from people trying to screw with you, either through messing with your script, how it's getting called, or by them just, owning you as a bad admin, expressly, if you want to make yourself safe at the cost of flexibility, we already paid flexibility by doing an explicit path instead of the user bin env shit. So we've already paid for that by doing that, right? There's supposed to be no shebang line in prepend. No, you should never have // You should never have period in your path, ever. You should never have dot. You really shouldn't have dot in your path either. You should always be forced to run things that are in unexpected locations by using // And it's a pain in the butt to type those extra // I know. If you want to do it for a single session, fine. Maybe put it in your session, in your running interactive session, so that you can do that. But don't put it permanently in your path. It's a bad idea. But if you want to be protected from this, and you want to make your shell scripts protected from the rest of the world, you can go you can explicitly define the path and say, so you can say the path is this, and now it will only run stuff that's there. So let's try this. I'm going to actually run my Z command using this. My Z command is in my own home path, and it's not there. Let's see if it runs. Will it run? What do you think? Will it run? Will it run? Will it blend? No, because it can't find it. So I can go here, which is Z, and I can incrementally add all the places that I would support Z. Now, Z is in a local directory, so I've taken liberties with that. I've added to my rather lengthy interactive path. But if this is specifically for things like system scripts and stuff, so you wouldn't want to do that, right? So like if you're writing like a system script that needs to run in your init, and it's going to run as root, and it needs to have high security, this is the thing to do. But a lot of the people that are writing shell scripts and stuff, a lot of times when they get asked to write like a system level like shell script that's running as root or some advanced permissions, they don't think about these things because they're used to writing their quick and dirty shell scripts for whatever thing that they do at home. And that's how I am. I have to kind of switch modes and say, okay, I'm writing secure scripts now. And this is the kind of thing that shell check won't check for you. Shell check isn't going to say your path is insecure. It's not going to say that to you. So this is one of those things that's not going to be caught. But this is cool. And so on to the extent that we can, this is actually going to protect this. But here's what's really cool. It's going to make sure it runs. But if you can actually write a script that checks the safety and dependencies of your other scripts, because sometimes you don't know. So like, what if you did this? Like echo, right? Is it going to work? Well, is echo a script? There is a script called echo, right? But what script, what echo is going to be used when you're running? Well, echo is a shell built-in, but there's also an echo command because shell, right? This is the difference between bash and POSIX shell compliance, right? How about this one? This guy, that's actually a shell built-in in bash. But guess what? In POSIX shell, it's a command. It's actually a command. You can edit it. It's an ELF binary, and you can read about it. It's actually, the documentation on it is man test. and you read about it. And this is the thing. All of this stuff was incorporated into Bash as a built-in, and that's why Bash is more safe than POSIX. It's not even using the path for half the stuff anymore. It's got it all built in, such as echo, conditions, the double brackets. All of those things have been built into Bash. It's why Bash is more secure than Z Shell, than Fish, than POSIX. And people will tell you opposite, and they'll cite shell shock or some shit like that, and they don't know what they're talking about. So if you go like, yeah, and boy, yeah, man test is like, I am reading man test constantly because this tells you this is the fastest way to get to all your commands. Now, frankly, I don't use a lot of these. Like if I want to check for the existence of a file or something, I might check it, but that stuff is also in, yeah, it's also in help test. Help, when you use help from the command line in Bash, it runs through the man page and gives you the section that matches it. It's different than the man page. So, and it's manual. It's, by the way, not women, right? So you can do help test and you'll get the section from the Bash man page that's accurate. Man test is looking at the command test, which is a different thing. They're compatible, but it's a different thing. In fact, there's a lot of extra checks that you're going to not see if you do a help, if you do the help one. So use help. Help is literally the Bash help, and you can look up any command using this, including double brackets. It'll tell you about the expression, and it jumps right to it, so you don't have to scroll through the like 600 pages of Bash man page. All right, so that's one thing. But here's something cool. So what happens if we get rid of our path completely? What happens if we get rid of our path completely? What's going to happen? Well, kind of a fun thing happens that I just discovered. This got me wanting to make this video, and I actually made a script for this, and I'm gonna show you in a bit. So you can actually do this. You can say temp foo, right? And you're like, oh, what? There's no such file or directory for ls. So you can actually identify every subshell in your program by, and we talked about subshells before and how they can mess you up, particularly when you use them with cat. Never cat a pipe, never cat anything and pipe it into anything else because it shadows variables. It's very, really subtle, and I made a whole video on it. But when you're doing this, right? When you're doing this, when you're doing this kind of thing, sometimes you just might want to say, what kind of subshell dependencies do I have? How efficient is my program? Do I have 65,000 subshells because I'm using set octr and cut and all this shit that I don't need because I could do the bash parameter expansion as God intended? Or you know, how much dependencies do I have? Well, one of the cool little tricks you can do is just set path to nothing. And your program probably won't run, but it won't run. But here's the thing. When it doesn't run, it actually, cat and cut. They're both subshells. So like, watch, if I do cat here, is it going to work? Let's see if it has a subshell. Nope. Can't find cat. Doesn't exist. Right. So I was able to, now, if you want to get really, really pedantic, and I don't know if I would even do this. Some people do though. I've seen code that does this. It's so security focused. It has hard coded paths to the places that stuff is supposed to live. And that shell script is very specifically for a very specific systems. It has fully qualified calls to any binary in the script. And that is kind of a third level of real intense paranoia where you don't have a path at all. You know, and you explicitly say you're gonna go to those things, right? And I myself, that's a little bit too much for me even, right? But that does get by the empty path. And the other thing you can do with that too is it's like, well, where are my dependencies? You said, if you just go into your script, you're concerned about security, go to the top of your script and export path and make it blank. And if you can run the thing in a test-driven environment on a container or something, it's not going to blow stuff up because your script is so important. You can just do this, and then you can like incrementally come back and add user bin. You can add user bin here. You can say, okay, now I can take cat. Now cat will work, right? It'll work because it can find it. And you can slowly and quickly add those back. Now, the next stage of this is, and I wrote this in a script, in a Zet, which I think I have still up. Nope, I don't. So I wrote this in a Zet post. So this is going to go in the description. But, and I'm just restating here the stuff I've been doing. Set path to nothing to distinguish built-ins. And then I was like thinking, you know what? You can actually put this little trick in a script. You could put it in a script and call it no path. And you can, this is cheating. It says, hey, I'm going to look up the full path to the first argument, right? I'm going to look up the full path to the first argument, and then I'm going to completely zero out the path, and then I'm going to run the program. And exec says, replace my current environment, ioctl, everything, all the environment variables, everything. Replace my current environment running command with this command. That's what exec does, and that's why you want to use exec a lot of time when you can. It's always the last thing your script will ever do, because it discards everything it was using previously, all the memory, and replaces it with all of the same environment variables and hooks and everything that came, including open file descriptors, which is really cool, with the new thing. And so it opens the new thing and it runs it. But this time the child that is just exec'd off doesn't have a path. So the cool thing about this is that when you try this out, you can run it on LS and different things, and you can actually just, without modifying your program at all, you can just kind of see what it depends on. You can see how many subshells it has. And if you want to eliminate the subshells, you can take time to do that. So you can say, and I actually wrote this, it's called no path, right? So I can say no path ls. Oops, did I delete it already? I guess I did. I deleted it because I was going to write it together with y'all. In fact, let's do that. Let's just go write it. It's not that hard. So I have a program called newx that makes a new command in the place that I like to make commands, and I'm going to call it no path, and it gets it all set up for me. So the first thing is we're going to say, so the actual command, let's say this. Let's say cmd. So is cmd equals, you can use which, use command-v, whatever, and it looks up $1, and there's really no reason to do anything else here, because there's nothing they can really do fancy. If you want to put quotes, fine. And then what? Then we're going to export path equals and zero the path out, and then we're going to exec the command, and that's going to just run the command. Truth be told, you know what? If we were going to do this right, let's make sure to pass it all of the environment variable. I forgot to do that in the other one. I just caught that. So that's how you pass all the arguments on to the next thing. That means all of the arguments actually that were sent to the original. Instead of backtick, yes, you're right. It is a shell script. So good point. So you're right. You're absolutely right. And so let's do exec command, and then this is all of the arguments that were passed. I think we're going to need to shift that though, now that I think about it. This is new. I didn't do this one because the first argument is the actual command. So we need to get that off of there and pass those. We've already got the command out there. We adapted it and made the command replace command. Okay. We could have done a nifty parameter expansion there, but whatever. So that should work. Let's try that. So if I've got that, now I should be able to do no path ls and run it just fine. I should be able to no path -l and do that just fine. And again, you see that it's working just fine because the ls command doesn't need a path environment variables at all. It's completely independent, right? Another thing you could do is you could do no env. You could actually eliminate all of the env variables and see if it still works. That'd be cool. If I try to do this with my Zettelkasten script, it will fail. Why? Because I've got dependencies on things like sort and make directory and stuff like that. So just by looking at all the ways that it fails, I can count how many subshell dependencies I have, and I can see where I can maybe make some efficiencies. Could I rewrite sort as an internal function in bash and then get rid of that dependency? Can I make a directory from make directory that would be a hard one to replace with bash only, but I'm sure it can be done. I don't know. So, but you may not even know, and that's what I'm talking about. If you look at my Z script, there's so much code in here. What stuff in here is actual shell code, and what stuff is a dependency? And by the way, if you're using a lot of pipes in there, sedoc and stuff, every one of them is gonna blow up because it's a different subshell. So the takeaway from this is, if you want to count your number of subshells and you want to be able to start using like highly secure shell scripts, you need to be able to manipulate your path. And you need to be able to run some sort of script to test what your dependencies actually are. And that's it. My dog wants to go out for a walk, I think. I can hear her barking. So I'm gonna stop the stream. I will be back in 5-10 minutes or so, and we'll keep going with this. But YouTube video should be up. Do all the things. Make sure you come hang out with us.